Good evening, students. Today we are discussing about how to calculate the hybridization shortcut method we are discussing. So now first of all coming to example number 1, that is the BeCl2. This is the BeCl2, beryllium chloride. So this beryllium chloride hybridization, how to calculate? This is what is the hybridization, that is the sp hybridization or sp2 or sp3. How to calculate? Shortcut method only. So first of all we have to take the central atom. Central atom, what is that? That is the beryllium. First write down the configuration, that is the 1s2 and 2s2, that is the electronic configuration. Now it having how many valence electrons? This is the first shell, this is the second shell. So total second shell is the valence shell. Here how many electrons are there? 2 valence electrons are there. Then beryllium having 2 valence electrons. So central atom valence electrons write down as a, keep it as a dots. Now surrounding atoms, what are those? Chlorine atoms are there. So chlorine, already we know chlorine atomic number is 17. It needs one electron to get the argon configuration. Why? Because 17 plus 1, that is the 18. So argon configuration, if it is getting, then it is getting the stability. So chlorine needs one electron. So around the beryllium, how many electrons are there? 2 electrons are there. This electron give to the one chlorine and this electron give to the another chlorine. Then this bond pair you have to take it as a S. So you have to start from S. After that P. So this is the which hybridization? That is the sp hybridization. This is sp hybridization. So sp hybridization. So what is the central metal? This is the beryllium is the central metal. In beryllium, 2 electrons, valence electrons are there. This electron is shared by the chlorine atom and this electron is shared by the chlorine atom. So then what is the shape of this? This is the linear shape and bond angle, this is totally linear shape and bond angle is 180 degrees. 180 degrees. So this is BeCl2 calculation. So one more example. For example, BF3. So BF3 hybridization, what is the hybridization we are calculating? So first of all, what we have to take? Central atom we have to take. What is the central atom? Boron. Write down the configuration, that is the 1s2, 2s2, 2p1, 2s2, 2p1. So how many valence electrons? This is the first shell, this is the second shell. How many valence electrons are there? 3 valence electrons. So that 3 valence electrons, keep it as a dots. Now fluorine already we know that is the atomic number is 9. If it gains 1 electron, then it is getting the neon configuration. So each fluorine needs 1 electron. So around the boron, 3 electrons are there. So this electron give to the one fluorine and this electron is give to the another fluorine and this electron is give to the another fluorine. So totally 3 fluorines are there. 3 fluorines needs 3 electrons. So totally completed. Then this bond pair take it as a S and this bond pair take it as a P and this is another P. So totally what is the hybridization? sp2 hybridization this is. So BF3 is a sp2 hybridization. Next structure observe. Boron is a central atom. So around the boron, how many dots are there? 3 dots are there. Each dot is shared with the fluorine. Each dot is shared with the 3 fluorines totally. So what is the shape of this? This is the trigonal planar. What is this? Trigonal planar. Trigonal planar shape and bond angle is 120 degrees. So this is the BF3 calculation. Next, one more example, CH4 calculation. How to write the CH4 hybridization? What is the CH4 hybridization? So what is the central atom? That is the central atom is a carbon. So write down the configuration. That is the 1s2, 2s2, 2p2, 2s2, 2p2. So this is the configuration of carbon. So now this is the first shell, this is the second shell. So only 2 shells are there. Then which is a valence shell? Second shell is the valence shell. So in this, how many electrons are there? 4 electrons are there. So valence electrons, how many around the carbon? 4 valence electrons are there. So that 4 electrons we have to keep it as a dots, 4 dots. Now hydrogen, what is the atomic number? 1. It needs 1 electron to get the helium configuration. It needs 1 electron. So each hydrogen needs 1 electron. Carbon having 4 valence electrons. So these 4 valence electrons, each electron is shared with the 4 hydrogen atoms. 4 hydrogen atoms. Then this bond pair take it as a S and this bond pair P. this is P, and this is P. So totally what is the hybridization? sp3 hybridization this is. And coming to the structure, what is the central atom? Carbon is a central atom. Around the carbon, how many dots are there? 4 dots are there. 4 valence electrons only we are represented by the dots. So 4 dots are there. So these 4 dots are bonded with 4 hydrogen atoms like this manner. So now this is a, what is the shape? Tetrahedral shape. Tetrahedral shape this is. And what is the bond angle? This is 109 degrees 28 minutes. This is the bond angle. So like this we can calculate the hybridizations of any compound. If they given any compound, we can calculate based on this shortcut method. Only we have to write the central atom valence electrons we have to write, and surrounding atoms, so how many electrons it needs, those many electrons we have to give, and each bond pair we have to take it as a S, only one S, and totally 3 p orbitals and remaining d orbitals we have to give. And if so, like this we have to calculate the hybridization. So